Have you heard of identities before?
Um, yeah,
Okay.
my example, I had no idea what they were.
So how do you express identity? Or how do you
Isn't it like,
explain that to a layman?
isn't like both sides of the equation equal the same thing?
Very good. Very good. So identities are like equations. They are like equations which are always, and that's the key word here now, which are always true. So when something is an expression that is always true, then you call that expression an identity. Always true for any value of unknown. Any value of unknown. So the keyword, always true. If it is not always true, then it's not an identity. It means that it's just an ordinary expression. So the symbol,
Oh my God, bro.
the symbol is use equivalent symbol. So you can see that that symbol is different from equality symbol. So anytime you see that symbol used, the expression is talking about an identity. For instance, s minus 3 equals 2. S minus 3 equals 2. Is this an identity?
Um, no,
No.
yeah,
Why?
yeah, because like it
Because
equals something.
it's not
It
going
is
to
not.
be
It doesn't just both equal value.
it's not going to be true for all values of x. Do you understand that now? Look at the definition. Say
Mm.
identity are like equations which are always true for any value of unknown. So s minus 3 will be 2 only when s is what? 5. Do you understand that now? So s minus 3 equals 2 will only be true when x equals 5. Hence, s minus 3 equals 2 is not an identity. Is not an identity. But s plus 3 is equivalent to 3 plus x. So this is always true for all values of x. This is always true for all values of x. So we can now make conclusion and say that s plus 3 equals 3 plus x is an identity. Is that clear?
Yes, sir.
So let's see examples. Please give me a few minutes. Sorry, I'm back. So let's say example 1. This question says, prove that 3 into s plus 2 all squared minus s minus 4 all squared is equivalent to 2 into s squared plus 10x minus 2. So when you're done writing that, let me know. So to prove an identity, to prove that an identity exists from this expression, you prove the left-hand side to obtain the right-hand side, or you prove the right-hand side to obtain the left-hand side. Is that clear?
Yes, sir.
So let's look at, it's easier to pick it up from left-hand side. So from the left-hand side, we have 3 into x plus 2 raised to the power of 2 minus s minus 4 also raised to the power of 2. Now, two things you can do. If you like, you can open up the bracket. If you like, you can express this. I think that's the best way to go. because this is not difference of 2 square. So open up the bracket first in each. So 3 into, if I open up this s plus 2, that will give me s raised to the power of 2 plus 4x plus 4 minus, still retain the bracket because of the minus. Open up the bracket here, you have s raised to the power of 2 minus 8x plus 16. Then open up the bracket, the first bracket with 3, the second bracket with minus 1. So the first bracket, 3 will multiply each of the entity there. So that gives 3 square x plus 12x plus 12. Then open the second bracket with minus 1. So this will be minus square x plus 8x minus 16. Then collect like terms. So 3 square x minus square x, then plus 12x plus 8x, then plus 12 minus 16. 3 square x minus square x give you 2 square x. 12x plus 8x will give 20x. Sorry, let me open the board again. So this will give us 12 minus 16. I'm shaking it now.